In early June 2025, Earth experienced a severe G4 class geomagnetic storm, unleashing a cascade of geological events. Shortly after, a swarm of earthquakes rattled Idaho near Yellowstone, while volcanoes like Fuego in Guatemala, Kilauea in Hawaii, and Mount Etna in Italy erupted with renewed vigor. These simultaneous occurrences raise questions about the interconnectedness of solar activity and Earth's geophysical responses. As solar cycle 25 approaches its peak, scientists and observers alike are keenly monitoring these developments, seeking to understand the potential implications for global seismic and volcanic activity. This documentary delves into the recent events, exploring their causes, impacts, and the science behind them. Solar storms and Earth's geomagnetic response. On June 2, 2025, Earth was struck by a severe G4 class geomagnetic storm, one of the most intense in recent years. Originating from a powerful coronal mass ejection, CME, on the Sun, this storm sent a barrage of charged particles hurtling toward our planet. Upon interacting with Earth's magnetosphere, these particles caused significant disturbances in the geomagnetic field, leading to vivid auroras and disruptions in communication systems. Such storms are not just visual spectacles. They have profound effects on Earth's electromagnetic environment. The energy imparted during these events can induce currents in power grids, affect satellite operations, and potentially influence geological processes. The magnetosphere acts as Earth's shield against solar and cosmic radiation. However, during intense geomagnetic storms, this shield is compressed, allowing solar particles to penetrate deeper into the atmosphere. This compression can lead to increased ionization in the upper atmosphere, affecting radio signal propagation and GPS accuracy. Moreover, the induced currents, known as geomagnetically induced currents, GICs, can flow through pipelines and power lines, posing risks to infrastructure. These GICs are of particular interest to scientists studying their potential impact on Earth's crust and tectonic activity. Historically, significant geomagnetic storms have coincided with increased seismic and volcanic activity. While correlation does not imply causation, the temporal proximity of these events has prompted researchers to explore possible links. One hypothesis suggests that the induced electrical currents from geomagnetic storms could alter stress distributions along fault lines, potentially triggering earthquakes in already stressed regions. Similarly, these currents might influence magma movement beneath volcanoes, possibly accelerating eruptive processes. However, more research is needed to establish definitive connections. The recent G4 storm's timing is particularly noteworthy, as it coincided with a series of geological events, including increased volcanic activity and earthquake swarms. This synchronicity has reignited discussions within the scientific community about the Sun's influence on Earth's geophysical systems. Advanced monitoring tools, such as satellite-based magnetometers and ground-based observatories, are now being utilized to study these interactions in greater detail. Understanding the mechanisms behind these phenomena is crucial for improving predictive models and mitigating potential hazards. As we continue to observe the Sun's activity during solar cycle 25, it's imperative to monitor not only the immediate effects of solar storms, but also their potential long-term impacts on Earth's geology. Interdisciplinary research combining solar physics, geophysics, and seismology will be essential in unraveling the complexities of these interactions. By deepening our understanding, we can better prepare for and respond to the multifaceted challenges posed by our dynamic solar terrestrial environment. Idaho's earthquake swarm, a closer look. In early June 2025, central Idaho, particularly near the town of Stanley, experienced a significant swarm of earthquakes. Over a span of just a few days, more than 35 tremors were recorded, with magnitudes ranging from 2.0 to 4.0. The most substantial quake, a magnitude 4.0 event, struck shortly after 1:30 a.m., followed by several others in quick succession. This flurry of seismic activity has drawn attention from both residents and scientists, prompting questions about its causes and potential implications. While Idaho is no stranger to seismic events, the intensity and frequency of this swarm are noteworthy. Seismologists have identified this series of quakes as an earthquake swarm, characterized by numerous earthquakes occurring in a localized area over a short period without a single dominant main shock. Such swarms differ from typical aftershock sequences, where a significant quake is followed by smaller ones. In the case of Stanley, the swarm's proximity to the Sawtooth Fault, a known active fault line, adds another layer of complexity. The region has a history of seismic activity, including a notable magnitude 6.5 earthquake in March 2020, which continues to produce aftershocks. However, distinguishing between aftershocks and new swarm activity requires detailed analysis. The timing of this swarm, coinciding with a recent G4 class geomagnetic storm, has led some researchers to explore potential correlations. Geomagnetic storms can induce electric currents in Earth's crust, potentially influencing tectonic stresses. While the energy from these currents is relatively small compared to tectonic forces in regions already under stress, they might act as a trigger for seismic events. This hypothesis remains under investigation, but the temporal proximity of the geomagnetic storm and the earthquake swarm is intriguing. Further interdisciplinary studies are needed to explore this potential connection. Residents in the affected areas have reported feeling the tremors, though no significant damage has been reported. Local authorities have issued guidelines on earthquake preparedness, emphasizing the importance of drop, cover, and hold on during seismic events. The swarm has also sparked discussions about infrastructure resilience and the need for updated building codes in seismically active regions. Public awareness campaigns are underway to educate communities about earthquake risks and safety measures. Such initiatives are crucial in mitigating the impacts of future seismic events. Monitoring efforts have been intensified, with the U.S. Geological Survey, USGS, deploying additional seismometers to better understand the swarm's characteristics. Data collected will aid in determining whether the swarm is diminishing or if there's a risk of larger quakes. The situation underscores the importance of continuous seismic monitoring and research, especially in regions with complex geological settings. As our understanding of earthquake swarms evolves, so too will our ability to predict and prepare for such events, enhancing community resilience. Yellowstone's seismic activity. Should we be concerned? Yellowstone National Park, renowned for its geothermal wonders, sits atop one of the world's most studied supervolcanoes. In early June 2025, following the severe G4 class geomagnetic storm, seismographs detected a slight uptick in microseismic activity within the Yellowstone caldera. While these tremors were minor and well within historical norms, their timing has reignited public interest and speculation about the potential for larger seismic events. The proximity of these events to the Idaho earthquake swarm further fuels discussions about regional tectonic interactions. However, experts emphasize that Yellowstone's current activity does not indicate an imminent eruption. The Yellowstone Volcano Observatory, YVO, continuously monitors the region using a network of seismometers, GPS stations, and satellite data. Their analyses show that the recent seismicity is consistent with background levels observed over the past decade. ground deformation measurements indicate no significant uplift or subsidence, and gas emissions remain stable. These indicators suggest that the magmatic system beneath Yellowstone is behaving normally. Nonetheless, the YVO remains vigilant, as the supervolcano's complex system requires constant observation to detect any anomalous changes. Public fascination with Yellowstone often stems from its classification as a supervolcano, capable of producing catastrophic eruptions. However, such events are exceedingly rare, with the last major eruption occurring approximately 640,000 years ago. More recent activity includes smaller hydrothermal explosions and lava flows, none of which have posed significant threats to human populations. The current seismic activity, while notable due to its timing, aligns with these less dramatic geological processes. Educating the public on these distinctions is crucial to prevent unnecessary alarm. The interplay between geomagnetic storms and seismic activity is an area of ongoing research. Some studies suggest that the electromagnetic disturbances from solar storms can influence Earth's lithosphere, potentially affecting fault stress levels. In regions like Yellowstone, already under tectonic stress, these influences might slightly modulate seismicity. However, the scientific community has yet to establish a definitive causal relationship. Continued interdisciplinary studies are essential to unravel these complex interactions and improve our understanding of Earth's dynamic systems. In conclusion, while the recent microseismic activity in Yellowstone coincides with other regional geological events, current data does not indicate any significant changes in the volcano's behavior. The YVO continues to monitor the area closely, ensuring that any deviations from the norm are promptly identified. Public interest in Yellowstone's activity underscores the importance of transparent communication between scientists and the community. By staying informed through credible sources, individuals can better understand the nuances of volcanic activity and the actual risks involved. Fuego volcano's eruption, impact on Guatemala. On June 5, 2025, Guatemala's Volcán de Fuego erupted, spewing ash and hot gases into the atmosphere and prompting evacuations. Authorities moved at least 594 residents from 5 communities across the Chimaltenango, Escuintla, and Zacatepeques departments to emergency shelters. As volcanic activity continued, officials anticipated more evacuations. Among those evacuated was Wilva Guerra from El Porvenir, who noted that although the eruption seemed manageable initially, evacuating early was a safer choice. In response to the eruption, authorities also shut down a nearby highway and suspended classes in 39 schools to ensure public safety. The eruption's intensity was evident as the volcano expelled ash clouds visible from San Juan Alotenango. The ash plume rose high into the sky, affecting air quality and visibility in surrounding areas. The Volcán de Fuego, standing at 12,300 feet, 3,563 meters, and located 33 miles, 53 kilometers from Guatemala City, is one of Central America's most active volcanoes. This event recalls the deadly 2018 eruption, which claimed 194 lives and left 234 people missing. The recent eruption, while less deadly, underscores the volcano's persistent threat to nearby communities. Residents in affected areas faced significant challenges. The ashfall contaminated water sources, damaged crops, and posed health risks, particularly respiratory issues. Emergency services worked tirelessly to distribute masks, clean water, and food supplies to those in shelters. Local schools and community centres were converted into temporary shelters, providing refuge for displaced families. The government's swift response aimed to mitigate the eruption's impact, but the long-term recovery would require substantial resources and support. The eruption also had economic implications. Agriculture, a primary livelihood for many in the region, suffered due to ash-covered fields and damaged infrastructure. Tourism, another vital sector, experienced a downturn as travel advisories were issued and attractions closed. The cumulative effect of these disruptions strained the local economy, highlighting the need for disaster preparedness and resilient infrastructure. International aid and support from non-governmental organizations played a crucial role in the immediate aftermath, providing relief and resources for recovery efforts. In the wake of the eruption, scientists and authorities emphasized the importance of monitoring volcanic activity and educating the public about evacuation protocols. The National Institute of Seismology, Volcanology, Meteorology, and Hydrology increased surveillance of the volcano, utilizing satellite imagery and ground-based sensors. Community engagement initiatives aim to raise awareness about volcanic hazards and promote preparedness. The 2025 eruption served as a stark reminder of nature's unpredictability and the necessity for vigilance and proactive measures to safeguard lives and livelihoods. Kilauea's renewed activity, insights from Hawaii. On June 4, 2025, Kilauea volcano in Hawaii erupted dramatically, marking the 24th episode of its ongoing eruption series that began in December 2024. This latest event featured lava fountains soaring nearly 1,000 feet into the air, illuminating the night sky and captivating observers. The eruption commenced at approximately 8:55 p.m. local time, with activity intensifying rapidly as lava burst from both the north and south vents within the Halema-Umahu crater. The spectacle was visible from various vantage points within Hawaii Volcanoes National Park, drawing attention from scientists and tourists alike. Such powerful displays underscore Kilauea's status as one of the world's most active volcanoes. The eruption's vigor was not only visually striking, but also scientifically significant. According to the U.S. Geological Survey, USGS, the lava fountains generated a volcanic plume that reached approximately 16,500 feet above ground level. This towering column of gas and ash posed potential hazards to aviation and air quality, prompting the issuance of alerts and advisories. The eruption lasted about 7.5 hours, concluding in the early hours of June 5th. Throughout the event, seismic activity and ground deformation were closely monitored, providing valuable data on the volcano's behavior. Such information is crucial for understanding eruption dynamics and forecasting future activity. Kilauea's recent activity is characterized by episodic eruptions, with periods of heightened activity followed by relative calm. This pattern has been ongoing since late 2024, with each episode offering insights into the volcano's internal processes. The June 4th eruption was preceded by signs such as increased seismic tremor and ground tilt, indicating magma movement beneath the surface. These precursors allowed scientists to anticipate the eruption, highlighting the importance of continuous monitoring. Understanding these patterns aids in hazard assessment and public safety measures. The eruption's impact extended beyond the immediate vicinity of the volcano. Volcanic gases, particularly sulfur dioxide, were released in significant quantities, leading to the formation of volcanic smog, or VOG, which can affect air quality downwind. Communities in the path of the VOG experienced reduced visibility and potential health effects, prompting advisories from health and environmental agencies. Additionally, the deposition of volcanic glass strands, known as Pele's hair, posed risks to both people and infrastructure. These hazards underscore the far-reaching effects of volcanic eruptions and the need for comprehensive response strategies. In response to the eruption, authorities implemented safety measures within Hawaii Volcanoes National Park, including temporary closures of certain areas and the dissemination of information to visitors. The USGS and other agencies provided real-time updates through various platforms, ensuring that the public remained informed. Educational initiatives emphasized the importance of preparedness and awareness in volcanic regions. The June 4th eruption serves as a reminder of the dynamic nature of Earth's geology and the necessity for vigilance in the face of natural hazards. Continued research and monitoring are essential for mitigating risks and enhancing our understanding of volcanic activity. Mount Etna's pyroclastic fury. The June 2nd eruption. On June 2nd, 2025, Mount Etna, Europe's most active volcano, erupted dramatically, sending a massive plume of ash, gas, and rock into the sky. The eruption began around 11:24 a.m. local time, originating from the volcano's southeast crater. A partial collapse in this area triggered a pyroclastic flow, a fast-moving current of hot gas and volcanic matter that raced down the volcano's slopes. The ash cloud rose approximately 21,300 feet into the atmosphere, nearly twice the height of the volcano itself. Despite the intensity, authorities reported no immediate danger to residents, as the lava flow remained confined and away from tourist zones. Tourists visiting Mount Etna during Italy's national holiday, Festa della Repubblica, were caught off guard by the sudden eruption. Videos and images captured the moment visitors fled down the volcano's slopes as smoke and ash billowed behind them. Some tourists paused to take photographs, while others scrambled to safety. The eruption's timing during a busy holiday increased exposure to the event, highlighting the volcano's ongoing active status and the risk it poses to nearby communities and tourists. Despite the dramatic visuals, no injuries were reported. The eruption's impact extended beyond the immediate vicinity of the volcano. The ash plume prompted the issuance of a red aviation alert, as the volcanic ash posed potential hazards to aircraft. Nearby, Catania Airport remained operational, with flight safety being actively monitored. Volcanic gases, particularly sulfur dioxide, were released in significant quantities, leading to the formation of volcanic smog, or VOG, which can affect air quality downwind. Authorities urged caution and restricted tourist access to the summit area due to the volatile nature of volcanic activity. Mount Etna's eruption was captured from space by the European Space Agency's Copernicus Sentinel-2 mission. Satellite imagery revealed the massive plume of ash and smoke erupting from the volcano, with lava flows visible on its slopes. The eruption was the 14th eruptive phase in recent months, indicating an increasing frequency of Mount Etna's paroxysms. Experts noted that the eruption was likely triggered by a partial collapse of the volcano's southeast crater, a phenomenon that has occurred in previous eruptions. Despite the eruption's intensity, it was classified as a medium-sized event by Italy's National Institute of Geophysics and Volcanology. In the aftermath of the eruption, authorities emphasized the importance of monitoring volcanic activity and educating the public about evacuation protocols. The eruption served as a reminder of nature's unpredictability and the necessity for vigilance and proactive measures to safeguard lives and livelihoods. Mount Etna, standing at approximately 11,000 feet, continues to be a significant tourist attraction, but its persistent activity underscores the need for comprehensive response strategies and public awareness. Continued research and monitoring are essential for mitigating risks and enhancing our understanding of volcanic activity. The global chain reaction. Volcanoes stirring worldwide. In the wake of the severe G4 class geomagnetic storm on June 2, 2025, a remarkable pattern emerged. Multiple volcanoes across the globe exhibited increased activity. From the Americas to Asia, seismic and volcanic monitoring agencies reported heightened unrest in regions previously considered dormant or stable. This simultaneous awakening of volcanoes has prompted scientists to investigate potential correlations between solar activity and geological responses on Earth. While the exact mechanisms remain under study, the temporal proximity suggests a possible link worth exploring. In South America, Colombia's Nevado del Ruiz volcano emitted ash plumes reaching several kilometers into the atmosphere, disrupting air traffic and prompting evacuations in nearby communities. Similarly, in the Philippines, Mount Mayon showed signs of increased magma movement, leading to the elevation of alert levels and the establishment of exclusion zones. These events, occurring shortly after the geomagnetic storm, have raised questions about the potential influence of solar-induced electromagnetic disturbances on volcanic systems. Researchers are now analyzing data to discern patterns and causative factors. In the Pacific Ring of Fire, a region known for its intense tectonic activity, several volcanoes displayed unusual behavior. Japan's Sakurajima volcano experienced a series of explosive eruptions, while Indonesia's Mount Sinabung emitted continuous ash clouds, affecting air quality and agriculture. These occurrences, in conjunction with the global uptick in volcanic activity, suggest a broader geophysical response potentially triggered by external cosmic events. The synchronization of these eruptions has become a focal point for volcanologists worldwide. Africa, too, witnessed increased volcanic activity. Mount Nyiragongo in the Democratic Republic of Congo exhibited signs of unrest, with lava lake levels rising and seismic tremors detected in the vicinity. Authorities issued warnings to residents, emphasizing preparedness in case of an eruption. The widespread nature of these volcanic responses underscores the need for a comprehensive understanding of the factors influencing Earth's geodynamic systems, including potential extraterrestrial triggers. The global pattern of volcanic activity following the geomagnetic storm has reignited discussions about the interconnectedness of Earth's systems and the potential impact of solar phenomena on geological processes. While causality has yet to be definitively established, the correlation warrants further investigation. Advancements in satellite monitoring and geophysical instrumentation will play a crucial role in unraveling these complex interactions, ultimately enhancing our ability to predict and mitigate volcanic hazards. Solar Cycle 25. The Sun's role in Earth's volcanic activity. Solar Cycle 25, which began in December 2019, has been marked by increased solar activity, including sunspots, solar flares, and coronal mass ejections, CMEs. These solar phenomena can have profound effects on Earth's magnetosphere, leading to geomagnetic storms that can disrupt communication systems and power grids. The recent G4 class geomagnetic storm on June 2, 2025, is a prime example of such solar-induced disturbances. As Solar Cycle 25 approaches its peak, scientists are closely monitoring the Sun's behavior to understand its potential impacts on Earth's geological systems. The connection between solar activity and Earth's geological events, such as earthquakes and volcanic eruptions, has been a subject of scientific inquiry for decades. Some researchers hypothesize that the electromagnetic energy from solar storms can influence tectonic plate movements by inducing electric currents in Earth's crust. These currents could potentially alter stress levels along fault lines, possibly triggering seismic events. While the exact mechanisms remain under investigation, the temporal correlation between solar storms and increased geological activity is compelling. The June 2nd geomagnetic storm coincided with a series of volcanic eruptions and earthquake swarms around the globe, including significant activity at Mount Etna, Kilauea, and Fuego. This synchronicity has reignited discussions about the Sun's influence on Earth's internal processes. Advanced monitoring technologies, such as satellite-based magnetometers and ground-based observatories, are being utilized to collect data on these events. By analyzing this data, scientists aim to discern patterns and establish any causal relationships between solar activity and geological phenomena. Understanding the Sun's role in Earth's geological activity is not only of academic interest, but also has practical implications for disaster preparedness and mitigation. If a definitive link is established, it could enhance predictive models for earthquakes and volcanic eruptions, allowing for more timely warnings and evacuations. This interdisciplinary research, bridging solar physics and geoscience, represents a frontier in our quest to comprehend the complex interactions between celestial and terrestrial forces. As Solar Cycle 25 continues to unfold, the scientific community remains vigilant, recognizing the Sun's potential to influence Earth's dynamic systems. Ongoing research and collaboration across disciplines are essential to unravel the mysteries of these interactions. By deepening our understanding of the Sun-Earth connection, we can better anticipate and respond to the challenges posed by our planet's ever-changing environment. Idaho earthquake swarm. What's shaking beneath Yellowstone? The Idaho-Yellowstone region, part of a broader geologic hot zone, has long been on scientists' radar due to its seismic sensitivity and proximity to the Yellowstone supervolcano. Just after the severe G4 geomagnetic storm on June 2, 2025, a surprising increase in earthquake activity was recorded in the Idaho region. These swarms, clusters of small to moderate quakes, may not make headlines individually, but collectively, they often indicate deeper tectonic shifts. Researchers began correlating the timing of these tremors with fluctuations in Earth's magnetic field caused by the storm. What makes these Idaho tremors especially concerning is their close geological relationship to the Yellowstone caldera. Though Yellowstone itself hasn't shown dramatic uplift or thermal anomalies in recent weeks, the interconnected nature of tectonic stress makes the swarms worth watching. Swarm patterns can indicate magma movement or adjustments in fault systems. This kind of tremor activity often precedes larger geological events, and while it's not a sure sign of eruption, it's certainly a red flag for geologists. Compounding the tension is the solar trigger hypothesis. Some experts believe the G4 storm's geomagnetic disturbances may have subtly altered tectonic stress, causing these small earthquakes to ripple through fault lines already under pressure. This idea, though controversial, is gaining interest as more events seem to align with solar cycles. If electromagnetic surges can trigger fault slippage, it would completely change how we forecast earthquakes, especially in sensitive areas like this. Emergency preparedness teams across Idaho and Montana have already taken notice. Local agencies have started issuing public awareness updates, encouraging communities to review evacuation plans, especially in towns near Yellowstone's perimeter. Though not in panic mode, authorities are operating with increased vigilance. The connection between celestial weather and crustal stress may still be emerging science, but on-the-ground responders aren't taking any chances.